Hi students, I am your Nirmala ma'am. So today I'm going to teach a one short video of physics. See, I have seen the lot of students are feeling very difficult physics compared to the chemistry and biology. So many students are asking me to do it a revision, short revision of the CBSE completely the four chapters. So that's why I'm going to do this short video of you people, and I'm thinking it's a more helpful for you. And if you are going to study now for your examination, before once you go through this video and after that you take it your books and read it, it's a more helpful and it's a good guidelines. I will give the complete surety for you people. And also you share this video to your friends, everyone, because they also has to get the benefit. I'm thinking, because who are joined in my online tuition, they are feeling more better now, because of they are feeling very easy now the physics chemistry after once they uh, join to the tuition and they covered and revision everything is after they are feeling so easy the science. So what I thought it to, I have to support for the all the students. I'm thinking, okay students, I'm not going to waste your time, because of this is a valuable time for you everyone. So I'm going to the directly to the concepts. So first I'm going to take your chapter light reflection and refraction. So very briefly I'm going to give, and this is a more helpful for you, and some tips also I'm giving to you to how to recall it, because of most of the students are doing the mistakes of the converging mirror, diverging mirror, converging lens, and diverging lens. They are, most of the people are confusing there. So that I'm going to give a small tip for you and to recalling of that one. And power also they are confusing, so what type of power of lens also, that is also I'm clear about that. And problematic, after this video I'm going to do a very short video for the problematic. It is also more helpful for you, I'm thinking, because of most of students are why they are feeling very difficult this physics is means for problematic. So definitely I can remove your barriers and your fear. Okay, let's move on to the topic. Look at here. In this chapter, what you are having means reflection. First, reflection. So, this reflection, about this reflection, you have studied in the previous standard. So, you know that if a light is incident to the any surface, definitely it will reflect. So, that in your real life, you are absorbed already. So if you go for the sunlight, the midday, if it is a water is stagnant in any way, the sunlight is instant to the water, the reflection come out. For that we are seeing of that color on that water. And any glass surface, it's a very smooth of the glass surface, the light incident to the, definitely the reflection we can see. So this is the reflection. And we are having one more here, that is normal line. So why we are taking the normal line means for taking of an angle. So this is perpendicular to this surface. So here incident angle is I and reflected angle is R we are taking. So what is the reflection loss? We are having uh, 2 points. So what are that means? The first one is, the first law is what means the angle of incident equals to angle of reflection. This is the first law. The second law, if you have seen, the second law is what means incident ray, normal, okay. So normal to the mirror and reflected ray. all these three are lies in the same plane. So this is the second law we are having. So incident ray, normal to the mirror ray. So next reflected ray. So these three are lie in same plane. So these are the two laws of the reflection law. Next you are having a spherical mirror. So spherical mirror means what is that means in the sphere we are taking a part. Okay, a sphere of a mirror we are taking a part, that is called the spherical mirror. So the spherical mirror we are having a two types. What are that means concave mirror. The another one is convex mirror. Oh, what is this, ma'am? We are going to take a part of that in the sphere only, right? How we can identify is it a concave mirror or convex mirror means how the light ray incident to that mirror. The based on that we are classifying this concave and convex. For example, the light is incident to the cave part. Look at here. This is a cave, that is a tip for you, so you can keep it, and the based on only here they have written concave. So this is a cave. Okay, so in that cave the light is incident. So light is incident, so which part it is incident, as in a cave. So then this is concave mirror. If a light is incident on the mirror like this, not on the cave side, now the behind of that mirror. So this is called convex mirror. So the other side is it is coated mirror, right? So the other side it's coated here. It one here, this side it is coated. Fine. Yes, good. So this is the mirrors. Okay, fine. So what you have to learn here means you have to learn about the principal axis. So this is clear about for you means the problematics is very easy for you. So listen carefully here. So definitely the sphere is having a center, right? In that some part we have taken. So this curvature is also having a center. This center is called the curvature, center of curvature, because curvature we have taken curve. One curve we have taken. So this is the center of this curve. So center of the curvature, and the line passes through the center and touches to the mirror. That line is called the principal axis. Next, so here that touches the mirror, that is called pole. We are denoting with the P. And the between center of curvature and pole we are having a focus point. So what is the focus point means? So all the reflections are meet at a one point. That point is called the focus point. For example, if you have seen here that light incident to this mirror and it will reflect, right? It reflected, it passes through one point, all the reflections. So I will draw now. So look at here, this light is incident and it's reflected. So here, so all the reflections are meet at one point. So that point is called focus point. So many times asked in your previous question papers. So what is the focus point? Focus point is a nothing but a point. It is lies on the principal axis, and where all the reflection lines are meet at a one point on the principal axis, that point is called the focus point. And from center of curvature to pole is a radius. And focus point to pole is the distance is a focal length. So what is the relation between the radius of curvature and focal length means it is double. The radius of curvature is double of the focal length, because if you see here the principal axis I am drawing. So C is lies here and P is lies and F. So exactly F is midpoint of the CP. So the FP is F and this total is R. So this is a double right now. So how much F to P distance? The C to F distance also same. So F equals to 2F. So now it's a clear I'm thinking. Now come to the convex mirror. Same, the convex mirror is also having a center and center, focus point, pole. But so where the light incident, that that side we don't have a center of curvature and focus. The behind of the mirror we are having. So once the light ray is incident, then it's reflected here. So it is passes here like this. So here also same thing, from center of curvature to pole is a radius of curvature and focus point to pole is a focal length, same everything. Okay, next we are move on to the representation of images formed by spherical mirror using ray diagrams. So now I am going to take here one ray diagram. I have taken a ray diagram here. So look at this. So concave mirror and convex mirror. So first case, this is the first case. So be careful to listen. So once if you listen means enough, then if you can own your own, in your own you can write it, but don't miss off that scientific words. Okay, so here the light is instant. Here's some source I am taking of the light source. So light is incident, that means here light ray is incident to the concave mirror. So where the reflection will pass us, I told you, or focus point, through the focus point, right? So it passes through the focus point. You understood this. Next, this one is a convex mirror. So convex mirror also, the light is incident here and the other side through the focus it will reflect. So these and all we can't see. Understand, this is we can't see what is happening here the back of the mirror. So we can see the incident and reflection only we can observe here. So reflection, this is the first case. So based on this case, so which mirror is convergent and which mirror is divergent, clearly we can confirm it. So which mirror is convergent? Concave mirror is convergent. Why, ma'am, it is a convergent, and why the convex mirror is divergent? Let we know. So definitely. So look at here. Why the concave mirror is convergent means the reflection is towards the center. It's a towards the center. Here, away the center. It's not coming towards the center. It is away. Look at here. It is incident and it's going. So I'll remove this one. Then it's a clear of you. So it is incident and reflected here. So it is away, not towards the center. So it is divergent here in the convex mirror. In concave mirror, towards the center passes. So it is a convergent. Ma'am, how we can recall it as a past in the tension mind in a examination means. So one code I am going to give you people. So concave mirror, right? So here you see, I'm writing come means mirror. Okay. So come, con, come, con, quickly, divergent, I'm writing diver. The spelling is the mistake, I know that. But for your coding, I'm writing. So diver, vex. Okay. So come con quickly, driver, vex. Come con means what? The concave. Okay. So concave is convergent. Divergent is what? Vex. Vex means what? Convex mirror. So this is one code I'm giving to you people. The another code, full of con in cave. So cave means what? Mirror. I'm talking about here mirror. Full of con in cave. The driver vex to put in van through the mirror vehicle. Okay. So here you can any one of the code you can re, recall it. So this is the second one is very easy to recalling, I am thinking. So con means what? Convergent is the cave, concave mirror. Divergent is the vex, convex mirror. Mirror, if you keep it in your mind, it's a fully opposite to the lens. Okay. So that we will discuss in the later. This you remember. Okay. Next, move on to the second case. The second case is what means here the representing of a spherical mirror using ray diagrams. So now the ray is not incident directly to the mirror. The ray is passing through the focus point and incident to the mirror. So how it is the reflection? It's a parallel to the principal axis. Understood? So if the light ray is passes through the focus point and incident to a mirror, then it is parallel to the focus, it parallel to the principal axis. I am thinking it's a clear for you people. Next, come to the concave. So for concave also we are having a principal axis and it is incident, it is not incident to the directly to the mirror. So how it is passes through the focus point. So the I told you clearly the other side what is happening we don't know. So that's why orange line I am putting here. So how the reflection is there? It is parallel to the principal axis, the reflection. So observe in the both the mirrors, it's the same. The properties existing is the same. Understood? So this is incident I and this is reflection. Here also we are having this is incident and this one is reflection. Okay, clear, this case is clear. So now third case. Okay, ma'am. First, we have seen the case. First case is it's directly incident to the mirror, then it is reflected through the focus point. If the ray is passing through the focus point and incident to the mirror, then it is parallel to the principal axis. The second case, it's a good. For sometimes, because if you see from one source, the light rays, many infinite light rays is come out, right? For example, in our room, the light source is what? Bulb, electrical bulb, any bulb. Okay, so from that bulb, many rays are come out. So we are talking about only one ray because of for our understanding purpose. So such type of rays many can come out. So one is will be directly incident to the mirror, one is easy passes through the focus point, the another one is directly passes through the center. So this case also erased, right? Yeah, fine. So once that passes through the center, the reflection also passes through the center. So either in the concave or convex. Understood? Next, this is the second case. So only in where the reflection and incident is the same line, it passes through the center. The incident line is passes through the center. Next, the fourth case. So look at the fourth case. The fourth case is what? The light ray incident to the pole and it's reflected like this. That means here same I equals to R. Okay, so same we can observe in the convex lens. So already I told you the same properties. This is the representation of images formed by the spherical mirror. Now we are come to learn about the what are the cases in the concave mirror if the object places keeping based on, because in MCQs and 2 marks questions and they can ask the big question also to write the ray representation of the concave mirror, the image formation. So we will look at now. So first the image formation by concave mirror. So totally 6 cases are there. You are very well learned. I'm thinking that 6 cases. So once as a revision like that, listen that one, and it's who are not understand, definitely they can understand this, and who are good in this ray diagrams of image formation, just revision for them. Okay. uh, See, look at, I have taken concave, right? So rough, it's a very fast revision, that's why I'm not giving a label everything. So what are the important one only I'm going to give here. So the source we are taking at infinity. That means object is we are placing at infinity. So if at infinity, if we keep the light incident to the mirror, and already we discussed, and the reflection is passes through the focus point. And okay, ma'am, now we are discussing about image, where the image is forming. If we are keeping the object is at infinity, where the image is forming, that we need it, right? So the image is forming at the focus point. So how it is? We can see this. No, it's a highly diminished point size, highly diminished. That means more blur. Okay, and also point size. it's a like this point size, and also it's a highly blur. Oh, then how it is means it is real and inverted like this. So object you kept upwards, the image is formed downwards, and also it is a point size and diminished like this blur, and also it's a real image means left is left and right is right. Okay, so what you are looking to the mirror, that is not a real image, that is a virtual image, because your left is right, right is left. So that you can observe in the mirror. In your daily life you are looking your mirror, right? So that you can, that is a virtual. Okay, here it's a real, this first case. Okay, fine. So I am now, you are clear, right? So the the object is placed at infinity, image is formed here, image position, how it is highly diminished and real inverted point size. Okay, fine. So next case is, if you see, the object is placed beyond C, that means near to the sea. Understand? So beyond sea. Okay, where the image is forming now? Let me tell. Okay, let me tell. So where the image is formed. So the image is formed between center and focus point. Where it is forming? Between center and, okay, where the image is forming now, between center and here the image is forming. How it is also here? It is inverted, real and inverted, and also diminished. That means it's not a clear, it's not a clear. Okay, so where if you keeping this, this is object and this one is image. Now clear you are about the second case, right? So third case, we come to the third case. Okay, fine. So third case, where you are going to keep now? On center. So on center means the image is also forming at the center only. Understood? The image is forming also at center only. And one more thing here, how much of size of the object you have taken, same size of the image. Image is not a small. Understood? The image also same size of the object. And previous two cases, the image size is less than the object size. Here focus, here pole. Understood? So real and inverted same as like this. Yeah. Okay, next case is fourth case. So for fourth case, now what the option we are having between center and focus now? Step by step moving of the object towards the mirror. So now we are keeping here. So where the image is going to form? So here if you see, it's a beyond the center. And how it is the size of the image means it's more than the object. Enlarge only. So enlarge this one. So understood, right? Yes. So if I'm neatly, if I put the diagram, it's take a time. Okay, so now the concept you understand means enough, I'm thinking. Yes, right. So the object is placed here. So image is formed beyond the beyond C, right? And it is also enlarged. That means the size is more. Okay, what is the fifth case, ma'am? So what is the fifth case means? Look at here. At infinity is over. Next, beyond the C, that before the center of curvature is over, on the C is over, between C and F is over, where it has to keep on the focus point. Now the case. So on the focus point, if you keep the image is formed at infinity and also it's highly enlarged. Highly enlarged. The image is formed at infinity. Where the position of that object, the object is positioned on the focus point. This is the fifth case. Sixth case. So sixth case, now you are having the rest of only one case between focus and the pole. So only this case, that only this case, the image is forming behind the mirror. Behind the mirror, and also it is virtual and erect. It is virtual and erect. Understood? So it is not inverted. It is virtual and erect and also behind the mirror. Only this case is the image is virtual and erect. The which case between focus and the pole. Rest of all the five cases it is real and inverted. And also same side of the object the image is forming. So the last case only the image is forming the other side of the object. These are the six cases. Okay, fine. Now look at that convex mirror. So convex mirror, we are having only the two cases. So one case is the object is placed at infinity. So already I told you the mirror behind we are having here the center of curvature, focus point, pole. So now the light is incident and here it's reflected. Same. So incident, reflected. The on principal axis same. So incident, reflected. So at infinity, where the image is formed, ma'am, where the image is forming means the image is forming at the focus here behind the mirror. The image is forming, and how it is means virtual and erect. Virtual and erect. And highly diminished point size. This is highly diminished and point size. Okay, what about the next case means? We'll look at that. Next case. So where we are going to keep the object means we are keeping the object between infinity and pole. Here we are going to keep. So these are the two cases. One is the object is keeping at infinity. The another case is we are keeping the object where means at infinity, between infinity and pole. Okay, ma'am, where it is the image is going to form? That question it comes of you, right? See, always you have to put it the questions. Then only what type of questions they're asking also your mind can recall it. Okay, so now if you see here, mm, thing. So image where it is forming. So image is forming where I'll show you. So the image is forming here. You see the intersection here. Here it will form. So how it is means this image. This is imaged and virtual and erect. So both the cases, if you see the convex mirror, the image is virtual and erect. Understand? And real and inverted we are getting only in concave mirror. This is also you have to recall. Next, so what are the uses of concave mirror? So many times they are asking what are the uses of concave mirror. So concave mirror we are using in the torches. If the torch light is there, right? So front of that mirror, if you see, this is a concave because the light is incident to the cave. You are looking is the behind of that mirror. Understanding? So don't confuse the torches, the torch light focus you are looking, right? The light that is a mirror is a concave mirror. You have to understand, so which side the light ray incident, that is only we are considering which type of mirror. The light is the inside, so it is like this. It's a bowl like, right? You are looking this side, but light is incident to inside. So you are looking this side. If the mirror is like this, right? It's a spherical mirror. So we are looking this curve one this side we are looking, but light is incident to this way. That means what? Cave side it's incident. So that is concave mirror. Next, we are using as a headlights vehicles headlights, if you see, that is also concave. So don't confuse. Most of the students are asking me, ma'am, how it is the concave? It's a convex, right? So you are looking, your eyes is looking convex side, but where the light is incident, concave side, then it is a concave mirror. Okay, light incident is the based on we are classified. Next, shaving mirror. If we go for the salon and all, they are using shaving mirror. Shaving mirror is also concave mirror. And most of in the childhood 6th and 7th standard you have done one activity, right? So using some mirror in the midday and burning of the paper through the sunlight, that is concave mirror. Okay, so concave mirror is using for the sunlight to produce heat in solar furnaces. So these are the users. Understand? Next, uses of convex mirror. So what is the uses of convex mirror means? If nowadays everyone having a two wheeler, right? In the two wheelers, if you see rear view mirrors we are having, so driving time definitely we will look at that mirror and we will drive because of behind who is coming we have to know, then safely we have to drive. So that rear view mirror is a convex mirror. So what is the use of that rear view mirror? Many times asked in the um, board. So what is that means? So wide view we can see, wide view we can see of our behind. Okay, wider field of view we can see. So it will show our back of the view as a small way and a wider view it will show off in one mirror. So it's a clear of that. Okay, that is the use. Okay, fine. Now you are clear. Now we come to the main topic. So what is that means? Sign convention for reflection by spherical mirrors. This you understand means easy for you, problematic. Spherical mirrors. So what I am saying again, I am saying in this video, middle of you people, once go through this video, it's more helpful for you. And once if you go through this one short video, so then you take it that concepts and read very clear and very easy you will think of, right? Okay. And what is the sign convention? Yeah, we are having a sign convention here. So I'll take a mirror, spherical mirror, and principal axis. So now come to the graph. You know very well the graph, right? Drawing a graph. Always the horizontal line you are taking x-axis. Vertical we are taking y-axis. Same way the principal axis is here x-axis. Principal axis is what? X-axis. And you have to treat that spherical mirror as a vertical line, that is y-axis. You have to treat this mirror Mn is what? Y-axis. Then pole is a what? What is the pole here? Center. Origin is there, right? Same. We'll treat it. Okay. Next, you know right side, what is the sign of x-axis? What is the sign of x-axis? Positive. The left side, sign of the x-axis is negative. Understood? Next, object you are keeping here. So upwards means positive. Downwards means negative. Size. Next, where you kept here, this this side, left side. So the distance between the object to the pole is u. We are taking object distance. So image here we have taken, right? So image I'll write. So from image to pole is we are denoting as v. This is image distance v. So u and v is lies on the left side. Left side is x-axis what? Negative. So they won't give in your problematic positive and negative with the u and v values, object distance and image distance. So you have to take most of 99% the object is we are keeping on the left side. So object distance is negative. Next, focal length. Here you have to concentrate more. So focal length of the concave mirror is focal length of the concave mirror. Which side the focal length? Here center, here the another color I'll use. So center and focus. So which side is you are having a focus point? The left side. So focal length is what? Negative. The concave mirror focal length is negative. Next come to the convex. I'll write here. Convex. Convex is incident here. Object you are going to keep here. So the center focus point is lies on the right side. Right side is x-axis is what? Positive. So focal length is positive for convex lens. So don't forget this, children. Don't forget. So it's a more useful for you for doing of the problematic. So once again in the problematic doing time I'll teach you, but here also you have to listen carefully. So focal length is positive for the convex lens because which side it is? Right side. Understood? So it is a right side. An object is keeping which side? Left side. So U is negative. And image is forming in the convex lens which side? The right side only. Both the cases, right? At infinity and between infinity and pole. So both the cases it's formed in the right side. So V is positive. I think so you people understood. In here in concave mirror we are having 6 cases. In 6 cases, first 5 cases the image is negative. Only the last case where the which case that is the object is keeping between focus point and the pole. That case is the image is the right side. So that is positive. Only that case. Okay, now clear I am thinking. Next, magnification. So, excuse me. So, magnification m equals to h dash by h. So, what is h dash by h means height of the image by height of the object. The other form is minus v by u. Understood? Minus v by u. So, this is the magnification formula. Based on the what is the use of magnification, ma'am? Means you can identify which type of mirror it is. So if the magnification is negative, then how it is the nature of the image is real. If the magnification is positive, then how it is means virtual. So negative means clearly you can confirm it. This is concave mirror. Positive means we can't tell it is either concave or convex. Mirror. I think so. Mirror is clear. I'm thinking the reflection part is over. So I'm thinking it's a clear of you. This is the part 1 and part 2 I'm going to take the refraction of light completely. So please subscribe my channel and also please forward this um, video to all your friends, and this is most helpful for you. Thank you. Bye bye. Thank you, children. Bye bye.